Okay, we're going to get started in a second, so please come on in, find your seats, plug in your laptop. Ready to go? All right, good afternoon, everyone, and welcome to Saag. My name is Roman Dinelio, and I'm co-chairing with
Ben Kaduk.
So why don't we get started? First up, this is the note well. You've seen this in other meetings. This, of course, applies to the session we're having today. If you have any questions on what's there, please don't hesitate to come up to the mic and we can have a conversation about it. The agenda we have for you today is the usual one. We're going to open with talking about what happened in working groups or what will happen for those sessions that have not occurred. We'll talk about BOFs, one or two administrative items. This time we have 2 invited talks, and then whatever's left is open mic time to discuss anything you would like to talk about. Would anyone like to bash this agenda? All right, with that, let's roll. Thanks to all the working groups that sent their information to SAG. We're going to quickly skip through the ones that have reported. If you want to follow along, you can obviously go to the SAG mailing list archive, or in the slide proceedings, you'll see a URL to their status report. So we're good with ACE, Acme, COSI, Curdle did not meet, DOTS, EMU, I2NSF, IPSec-ME, Kitten, LAMP, SMILE. MLS is meeting on Friday. Is there anything that needs to be said there? Okay, we'll move forward. OAuth, RATS, SACM is meeting later today. Anything to say there? Okay. SEC dispatch, SEC event, no report. Anything to report? Negative. Okay, moving forward. Suit, MET, no report. Anything that needs to be said at the mic?
We sent a report 5 minutes before the meeting, so it is out there now. The only thing that we could add that's not in there is the TEEP working group has consensus to take a dependency on the suit working group and the RATS working group for that matter. And so that's just an inner working group that may be of interest to people, that suit and RATS now have a customer, which is us as TEEP.
Perfect. Great to see work in collaboration across the areas. There's TEEP. TLS, anything to say about Tokebind? Okay. Trans.
Right, Paul. There's one issue left again. We've been saying this for like 5 IETFs now. This time it's BSP 190 and how it affects the trans URI. Hopefully this will get resolved in the next couple of weeks, and then we'll submit RFC and close the working group again, hopefully.
And so they've got some discussion going on at the art area mailing list. That's right? Yeah.
Okay, there are quite a few other activities that happen across the IETF that are SEC related. This is a partial list, probably not a complete list. If anyone wants to come up to the mic to comment on any of those.
Hi, this is Elliot. I think I would just put Ops Area Working Group on the list in terms of we're doing a lot of MUD expansion, and one of the particular pieces of work that we'll be looking for guidance on is that there's a MUD reporter draft out there, which is RF-like, that might generate reports back to manufacturers. There are obviously privacy considerations throughout all this, and it's a very nascent draft. We're still trying to figure out what's going on. And so over time, we'll want people to just keep an eye on that one for us.
Elliot, sorry, there's no real monitor speaker pointing at us, so I'm not sure if everybody heard the name of the working group that's going on in.
Ops AWG.
Wendy Seltzer, W3C. We will send an update. And if you were in the paired research strip yesterday, you heard Pete from Brave speaking about some work in privacy considerations and specifications between W3C and IETF. I invite folks who are interested in those issues at the web application layer to come over and check out things that W3C is doing in our privacy interest group and in our web application security and web authentication working groups.
Thank you.
Dave Taylor, under external related, another organization is ITUT Study Group 17, which sent a liaison, or has sent multiple of them to the TEEP working group. They are doing related work. And fortunately, we have overlap in participants where the editors of the documents come to IETF and participate. Thank you, Tuck. And so right now we believe that we are aligned, but it is an external activity that we are tracking from within the TEEP working group.
This is Linda Dama from FutureWay. For the external related work, there's the ONUG, Open Network User Group. There's a software-defined security services is related to security service for the hybrid cloud. And also for the IETF, in the routing area, we had the IDR has quite a few contributions related to how to do controller or BGP to distribute IPsec parameters. So that's related to security.
You want me to mention the NetConf or?
Yeah, sure, absolutely.
Okay, Rich Sauls. NetConf has got a draft out for crypto types and actions and monitoring and so on. And anyone who's implemented any kind of cryptography will look at it and blanch. So I encourage everyone to look at it and blanch or expurge or do whatever you need to do.
Hi, Javner. So I want to mention the buff that we've had this ITF, Lake buff. So for those who weren't there, should have. There's been, well, at the start I was quite pessimistic. I didn't think that the content was but yes, we have a group of people wanting to work on this. It's about creating a lightweight authenticated key exchange for use in IoT, specifically requirements that came out of the OSCOR working group. And well, the people in the room were kind of split among people wanting to do something very narrowly tailored to the OSCOR working group and people who wanted to do something more wide-ranging. And of course, we already have two suggested solutions for solving this, even though the requirements are not, well, down yet. So it seems that there was enough enthusiasm to form a working group. I'm not sure that the scope is hammered down enough to do so, and I guess that's with the ADs now.
Yeah. Yes, per the ADs, thank you, Yov and Stephen, for chairing that working group. We were excited to see a lot of enthusiasm. The problem around an ache is understood, and we were excited to see enthusiasm around both OSCOR and a broader kind of solution, but we have some kind of tough choices to think ahead about how to actually proceed. So for those that participated, kind of thank you for the input. Stay tuned on how we're going to do next steps. Okay, so that runs to the end of our planned updates and gets us to talking about our invited talks. So I invite Dirk to come up and we're going to talk about PIDLOC related issues. Can you check that works? Did it actually clear? Oh, yeah, awesome. Oh.
So thank you to the area directors and to the chairs for giving us the chance to present our activity here on behalf of Bechet, who could not make it to Montreal. And my name is Dirk von Hugo. And we have this activity for some quite time with varying participation of people in the IETF community. And I try to describe what we were heading for and try to explain why we are interested in identifier locator split or separation approaches and why we think that common privacy consideration on the different solutions which are available could be of interest, and would like to see some reaction, comments, and how to proceed, how to focus. Yeah. Okay, first we'll start more or less on explaining what we think is meant with this identifier locator separation, and then also on privacy, which always comes up. I think if we talk about identifiers, which could harm the user's privacy, and also yesterday there was a technical plenary also on privacy, and a lot of the activity here in the SIG area is on privacy issues. We see some use cases where this should be especially interesting and perhaps may come up more than in past. Okay, the solution space is perhaps too early. There are some approaches, but we first want to see what are really the problem, what's the problem statement, and what are the requirements we have to fulfill, and after that, it's time for the next step. So with a traditional approach, routing between two IP addresses for a session between two endpoints identified by their IP address, this is working fine in end-to-end transparency, more or less, but in some cases it may not be enough efficient, maybe too complex, too much encapsulation and tunneling and detunneling and things. And for instance, one of the use cases is mobility, high speed mobility, extreme mobility with the IP addresses or the point of attachments changing very rapidly, and the session above cannot survive perhaps the change of the endpoints, so some applications needed. So that could be one problem. And of course also multi-homing or multi-path transparency, when you bind several paths and transport packets over different paths and have to recollect it, different IP addresses, and the session cannot live with this or need some more circumventions to solve this. And then also this issue with the cloud and with physical entities which are distributed but have one logical or virtual identity or entity and with their identity. And we think that this is something where a separation of the identity and the locator and using this, the identity as the endpoint with changing locators which are bound to the identity, more or less the different approaches are available. But this approach generally may be an advantage here and could at least help to survive the session. So yes, this is, there are multiple protocols and solutions and RFCs available, not only to mention here the Lisp, which is not only RFC 6833, this is the control plane part, but there's also 6830 for the data plane or user plane part. Then we have ILNP, which came out of research group activities. They are, for instance, RFC 6740, and then there's also a proposal by Tom Herbert with ILA, so Identifier Locator Addressing, which is in draft status. And they all, of course, care for their security and privacy by themselves and have solutions, but they are not yet or not deployed in a large scale. Of course, they are experimental, or also Lisp is going for proposed standards, or there are multiple deployments, not deployments, implementations there, and small-scale deployments, and ILA also for databases. But yes, there's not yet an operator who uses this approach for its network. And to have this approach directly, not as an overlay over another overlay also, would be, I think, kind of ideal solution. Of course, we need something which is also practical. And that's what we want to, that's the way we want to proceed, to see whether there is something on common ground of different approaches, perhaps kind of a more light solution, which of course nevertheless serves the same advantages for what these ID lock approaches have been proposed. So to reduce the burden of the IPv6 or IP address, which is normally handling both the identity and the location, which is, for instance, for the virtual machines with their different locations for the same identity, would be helpful. And then new network architecture is required for them, especially for Lisp. That's well, I would say a kind of totally new architecture. Of course, it can provide all this, the seamless mobility and so on, and of course also does mapping very fine. But it's for an operator, not yet. I've not seen one who says, yes, we deploy this in our network because we see that it's viable. So mapping systems can, of course, be use DNS for some, but also own mapping systems instead of routing tables to look up for. And in all these approaches, or I think in all, the source destination identifier is carried in the header to find the right location for the packet to distribute to, instead of the IP address in a usual or traditional manner or way. But what you see, especially as the applications areas, is now industrial IoT with the small messages and the could be large headers, much more larger than the payload, where such a new, well, not new, but sort of adapted approach could help. And of course also vehicular networks where all the UEs are moving the endpoint identities, and they very frequently change, of course, their location. And what all is included in 5G, maybe mobile network, might be wireless and fixed network, and or access technology, all combined together. These are all areas where this ID location would apply nicely to, but also, again, the privacy issue has to be solved or has to be considered enough so that there's no new privacy risk when using this. And I would like to go shortly on the different approaches which I mentioned, which are available. So the Lisp protocol is, as a network-based approach, uses an extra mapping system and encapsulates the packets, tunnels it between Lisp domains, and can also, of course, interwork with non-Lisp domains. But the new Lisp architecture, of course, could be a burden for deploying it into a running system. Okay, there are, of course, routers specified, new entities which do all this. And as usual, if you have the identifier and you need the locator, you have to query the mapping system. But only if it's necessary, of course. If it's not changing, you need not query again. So that's only the overhead if in case it's required. For instance, if a new flow is transmission is starting, or if the locator is changing. And there are, as I said, the different RFCs and updates to these RFCs now are under ISG evaluation. Sorry, as proposed standard instead of experimental. And there are, of course, more information on the Lisp.net on the existing deployments, and also, of course, for the Lisp working group information. The ILNP approach can be more seen as a host-based approach. The IP address is split into the locator and the node identifier. The locator, of course, is something which is significant for the topology and is used for forwarding and routing, and the identifier is denoting or naming the node, which may be physical, virtual, or logical node, and normally does not change. And what is the advantage here? It does not require any router changes. No new routers are required for this, and it uses DNS as the existing mapping system. But of course, this is perhaps not a good idea if we have very frequent queries for the mapping system. Of course, DNS is also evolving, and Salim, who could not make it here, has shown also in the hackathon on Saturday an implementation working with DNS extensions. And also there has been a tutorial on ILNP in meeting 102, and of course then there's a website for ILNP implementations. And the ILA-based approach uses to transform addresses also to split the existing IP address into the identifier and locator part, all 64-bit, and okay, we again have a mapping table to look up and determine which locator is fitting the identifier and is required. And this has been deployed in commercially already on IP layer, and there are also implementations available in Linux. So this is all which is working. And a special advantage is that the upper layer, UDP and TCP, don't need to change when using ILA. And there has been in 101 a buff on ILA, whereas there's more information also in the link given there. So that's what I want to say. They all have, of course, their own privacy considerations, but and also security, of course. But what we think is required if we want to go for a solution which is deployed by an operator, it could be something, a mix of all, or a new approach at least with perhaps new requirements to privacy. And that's what we want to investigate. And this, I think that's what I wanted to conclude in this slide. So why is the privacy important? Of course, because these identifiers in the packet header have to be transported anyhow to use it for routing also. And if there is, there are chances to break the privacy if they are transported in clear. So just generally. So, and that's also kind of a threat. And there, of course, are multiple versions of privacy leaks. So the location itself may be breached and may be available to others who are not allowed to. You need to know it, and not only the location, but also, of course, the movement. And by combining different information, this can lead to new risks. And of course, also that was something which in the multipath TCP, Marcello pointed out that if we have multiple paths, that increases also the privacy risk, because there are multiple informations, more than one on a location, and may lead or result in more precise location information for the adverse user, which should not do it. Yeah. Okay. There have been, as I said, solutions, proposals already for, and they have their own solutions as well in Lisp as in ILNP, and also for ILA, here only in a draft status at the moment. But the question is, why has it not been deployed so far? The question is privacy, of course, may be one of the reasons, but the deployment itself, that ID log systems are not deployed in networks today, is perhaps more the reason of the new architecture you need, of the new components you need, so you have to change a lot, and operators are not willing to change something if they are not sure about the positive outcome. So we also have to point on the advantage of it, of course. And one approach may be that the mapping system perhaps is not so complicated. So looking for a new mapping system may be one way. But we are not yet sure about this. Therefore, we see there's a lot of potential work we see, and we want to get done, and are looking for people to join us. We call it BitLog, privacy in identifier locator split approaches. We have a mailing list and have been since mailing list since IETF 102. And if we have clear what is our focused problem statement, which we can actually solve, we would like to go for above. Of course, beside the problem statement, would be interesting to start with requirements drafts and based on the use cases we have identified, and eventually we find a working group where the work has been done, or we get a new working group created for this to do then the actual work on solution space. And I think, I don't know what's the time, but
We have time for a few questions.
we have time for a few questions, yeah. And then the other slides are just for backup, are available in the proceedings, so you can look it up there, and you can join the mailing list there, of course, and review our drafts, which we have up to now in a very draft status, also published. Yeah, and then I would be happy to answer questions or get field interest.
Is there a reason to believe these problems are soluble?
Sorry?
Is there a reason to believe these problems are soluble? So you have a requirements, you have a problem statement. Do you have any proposed solutions?
One, you have a backup slide or
Second slide is.
That doesn't, yeah, that's not us.
I don't want to change it on the presenter.
slide
11. This approach by Tom Herbert on fast on the firewall and service tickets. That is a draft he has published. So that would be one thing we could discuss, but we still think we have to start more or less with a real problem statement before we go into the details.
I guess I'm just trying to figure out if this is a research problem or an engineering problem.
Research problem. Thank you.
Hi, Elliot Lear. I would just add on to what Ecker just said, which is I could envision this problem occurring not just in Lisp and ILNP, but you could consider it in the context of basic 802.1 VLANs. You could look at there's an analog to this that you could address in the context of MPLS VPNs. And so I guess there's a granularity issue, and I think it is an interesting research problem, but I don't know exactly where you'd like to define the granularity as to how you want to solve it, and having a little bit more clarity on that would be very helpful.
Let's alternate mics, please.
I'm sorry?
Let's alternate mics, but if you'd like to answer,
Sure.
if you'd like to comment on.
The comment on it's a research problem, yeah, we actually we still see it also as a research problem, but also we want to have it, a solution which is viable also for deployment. So I think it's perhaps a combination of both.
Hi, my name's Tim Shepard, and there's one, you named several identifier locator split systems, but the one that I was most fond of, and I think it's 10 plus or minus 5 years ago in the IETF, there was some work on HIP, host identity payload, and I didn't, if you mentioned it, I didn't.
Can you talk a little bit louder? It's really hard for us to hear on stage. I mean,
Oh,
the room is
sorry.
probably fine, but
I thought I'm hearing a lot of myself come back from the room. But so 10 plus or minus 5 years ago, there was a lot of work on HIP, HIP, and I don't think you mentioned it as your examples of things.
No, I mentioned this not because.
But that's fine. There's
just
probably lots of examples.
3 examples, yeah.
Yeah, but one of the things I remember from its story was that you could have ephemeral hits in that system, and the idea was you could create them. So, and now Bob is coming to the microphone. I think he was the originator of HIP. Anyway, I just wanted to point you at that as something you might want to also look at.
To also include in the consideration.
Yeah.
Okay, thank you.
To the other mic now.
I'm Rand Atkinson, and ILNP is my work in collaboration with Salim Bhatti at the University of St. Andrews. And I don't think ILNP particularly has any unique problems in this area. The same techniques in RFC 4941 that are used to generate IPv6 privacy addresses, those same techniques can be used with ILNP as is with the current ILNP RFCs and with the current ILNP implementations. So it's unlike slide 11 up there, ILNP's just leverages the solution work that's already been done to mitigate these risks with IPv6, and we don't need any special magic sauce that's ILNP unique.
So yeah, okay, I don't want to question this, that ILNP has its own security measures and privacy countermeasures, but ILNP is also not deployed by operators, and I think we have to look for something which is more easily to be deployed and perhaps raising new issues. Thank you.
Do you want to take Bob next?
We're just going
to... Bob Moskowitz, HC Consulting, the hipster, except when I get hit by a car on my hip. I'm a lurker on these lists. I followed along doing it. Aspects of HIP and hip bone are very similar to some of the issues being done here. I'll note that I have a work project on a privacy-based exchange, and I have a customer who wants me to get moving on it already, and a few other things. So there are things that HIP with its long-lived identities, which are definitely can be considered a privacy issue. There is work soon starting which will be addressing the privacy issues with HIP, just as an aside. But I've been lurking along and attended some of the sign meetings, so that the guys know me and I know them.
Okay, would you like to post this comment on our mailing list, perhaps? That would be nice. Okay, thank you.
Thanks, Roman. Robin Wilson. I'm glad to see this work being considered, because the more we think about privacy, the more we realize the importance of protecting data that's at the infrastructure layer and is very hard to obfuscate. So the fact that privacy considerations are high on the list is, in my view, a plus point. I think it's also valid to ask whether or not there's a solution to this problem, but only if we also recognize that solution is not necessarily a binary thing. There may be degrees of mitigation of the risks this involves.
Okay, thank you. I think we shall consider this our work.
Hi, this is Hannes. You mentioned that some of those solutions are being used in the IoT space and industrial IoT, and I was wondering whether you could shed some light on this topic.
Did I check what on that?
Explain what your experience is with that IoT or deployment of those technologies in the industrial IoT space.
Okay, yeah, we have some text on this in the draft, but I think we should investigate more on existing solutions. And if you can point to some, would be great. Yeah.
So Hannes, you're asking if there are existing deployments of this in IoT? Because that's what it sounded like.
From one of the slides, I got the impression that there's some deployment of this in IoT environments, and that's why I'm asking, because I haven't heard about it. Yeah, I can't contribute something in this space because I don't know.
Dino can perhaps clarify.
The problem is really, really hard because sometimes you just simply transfer the problem to someplace else. Your transport port numbers that long live. ESP spies, long-lived. How do you deal with those things that if you fix the address, you'll only just remove the problem to somewhere else in some other layer of the protocol? So there's still a lot of work to be done here and looked at very carefully, that you think you've solved the problem, but you've only solved what you think is the obvious problem, and there's just this other one lurking there as well. So it's still very much a researchy problem, in my opinion.
Yeah, and that also gets back into a lot of the work from the technology plenary yesterday.
This is Dino, Lispers.net. I have some experience with a deployment of industrial IoT. It uses Lisp with IPv6 EIDs. They're crypto EIDs because it has a association with a key pair, and we use encryption at the data plane to solve the privacy issues.
Okay, thank you.
All right, perfect. Thank you so much.
Okay, thank you for the comments, and perhaps you have a look at our mailing list and can help us. Thank you. Thank you for the
So next up on the agenda, we're going to switch over. Yari or Stephen are going to talk to us about exploring whether we need to extend the internet threat model.
All right. Yep. So the IIB had a workshop there a month or so ago in Helsinki about deployment realities versus design expectations. And two of the submissions were these drafts that Yari and I had written independently. We may merge that if depending what happens. Essentially asking the question, and there's Yari presented this at the routing area working group earlier in the week, and we had a quick discussion with the IIB and ISG about it. So if you look at 3552, that kind of describes an internet threat model that we kind of use when designing protocols. And the interesting part says two things. The first one essentially is that we assume that an attacker has complete control of the network, and that leads us to generate all sorts of ComSec protocols and to want to turn on ComSec mechanisms in protocols. The second thing it says is that we assume the end systems engaging in the protocol have not themselves been compromised. And I guess what we think is that thing one is still absolutely necessary. We shouldn't consider weakening that or doing silly things in that space. But thing two may no longer be sufficient, or maybe it doesn't map to reality anymore. And this is perhaps something worth looking at. I guess, I'd say that in defense of 3552, it may well be the case that as soon as you go beyond what it says, you run into problems that are so hard, there's very little you can do about it. So this may be a problem that's a bit too hard, or maybe there's things we can do. So again, looking at thing two and thinking about comparing it to the current reality, if we get better ComSec as a result of thing one, then that motivates attackers to look elsewhere. So the keys under doormats kind of things, or all those kind of stuff. Surveillance, I think, has been an issue we've talked about from the point of view of three-letter agencies. But also in the real world today, there's this kind of surveillance capitalism that kind of generates new risks because of the breadth of collection of information. The fact is that this is essentially unavoidable if you're using the internet today. And when we wrote 3552, the internet was a pretty different place. I think it's also true that even for a network that you think isn't really vulnerable, even if that's true at a particular point in time, some short time later, it's probably no longer true. So people who have thought that maybe they're designing applications or protocols in the IETF, who think, I have this bit of the network that's safe over here and nobody's going to touch it because it's behind a perimeter, that doesn't seem to be true nearly as much as you would think. And certainly that doesn't match reality. We have cases where we see competing interests involved in, so for example, the whole debate around applications doing DNS is a case in point of that, where different parties have different interests. And the threat model we have doesn't consider that. I'm not sure what you can do about it. But even more glaringly, if you look back at thing two, it says that end systems we assume are not compromised. And what the hell is an end system these days when you have virtualization, you have software-defined networking, and a whole bunch of other things that are really not what we would considered as the kind of host requirements, which is, I guess, kind of the mental model we might have had back then. So there's an argument that thing 2 is no longer sufficient. Ted suggested that we could do a poetic version of this, and there's 2 poetic versions. This is one. They're really horrible. This is the second one, also really horrible. And the only reason we put this up is you can guess who wrote which if you really care for it. And the picture in the back is kind of reflective of where we think we are a bit. But prose might be better as an output. So what might this activity be? I guess what we're thinking about, it'd be good to get people looking at this problem and trying to consider, are there things that we can do that better reflect reality, but also that are useful for people doing work in the IETF or elsewhere in designing protocols. That's kind of like, one of the nice things about 3552 is the threat model is nice and simple. In other places in the IETF, for example, there's an RFC for the OAuth threat model. It's a gigantic, complex thing, so it's probably not useful as generic guidance, even though it is a threat model that does include the idea that parties involved in the protocol may be colluding against one another. So we may end up with some kind of statements like this. The 4 of us, we all happen to be on the IAB at the minute, but this is not an IAB thing necessarily. We're looking for guidance and feedback. We think there could be some useful end results. So for example, we have in RFC 6973 some privacy guidelines that are not really part of the kind of IETF process formally, but that are useful, talking about things like data minimization. Maybe we can think about the fact that some of our protocols or some of our security mechanisms and protocols may be increasing tendencies towards centralization in ways that we'd be better off not doing. We may have some design process issues. So for example, in the IETF, somebody comes along and says, I have this use case I want to do, and they invent something that has a new identifier that's a long-term stable identifier that gets everywhere, and that causes privacy problems. Maybe we should be considering or encouraging people to think of abuse cases. So how can the thing you want to do be abused and build that into the design process? And that might be a simple little bit of guidance we could include. So we're not proposing right now to do a 3552 BIS. Kind of tried that, didn't work. I think what we'd like to do is get a bunch of people who are interested in this to work together. Maybe, I think Ted was going to try and see if we can set up a mailing list unless people say this is all crazy and you shouldn't do it. And we could just kind of work the problem with people who are interested in it, and perhaps after we've done that, to see is there stuff that can be said, and then see can you winnow that down to something useful that could apply to places in the IETF where people are doing this kind of work. Perhaps after that, we might want to come back and look at some kind of modification to the process and BCPs that we have. So we're not proposing to kind of dive right in there yet without doing a bit of preparation work, and we're looking for feedback. We're looking for people who are interested in being involved. And if people don't tell us this is all stupid and crazy, we'll probably set up a mailing list and send the coordinates to Saag. That's all I had.
Hi, Mohit Eriksson. So this is not completely crazy or stupid, so I think you should continue. I get that there is a need to maintain the balance, that if we open up saying that endpoints can be compromised, then we need to think how far they can be compromised and so on. Like, we are not here to protect against someone, do physically threatening you or things, but there are still some things we can definitely look at. So for a couple of examples that came to my mind, misbinding attacks, or at least I also spoke to Ecker about this, is something where one of the nodes participating in the communication is compromised, and then he misleads you to talk to some third party. And if you have a server database, whether you're using a symmetric PAKE or asymmetric or whatever, balance, imbalance PAKE, these kind of things do make effect of what happens when one of the nodes get compromised. And perhaps for us as protocol engineers, when we are designing these things, we could make a better choice and prepare ourselves for the case when one of the parties is compromised. Then again, we don't want to open the floodgates and let everything in. So definitely interested and would like to see this go forward. Need to be a little bit careful.
Thank you.
I didn't see the order in which people came to the mic, so let's just alternate.
Hi, Dominique Lazansky with myself, actually. Thank you for the presentation. This is extremely relevant, as you know. Sorry about missing the workshop. I didn't know it was going on.
I missed it myself.
Okay. As you know, I also have a draft, which is a new threat model, Smart Lazansky, for this particular meeting, which you've commented on as well. So I very much look forward to working with you. And in that draft, I do go through quite a lot of threats that are happening in the most recent years, in particular with malware, botnets, and data breaches. So hopefully we can fold that all in to have a more broader perspective. So I look forward to working with you. Thanks.
Thank you.
Dave Taylor, thank you. I didn't know about the workshop either until this IETF, but I'm interested in this topic. We actually have 2 working groups in this area that are meant for cases where thing 2 is not true. Those 2 working groups are RATS and TEEP. And so the point is, yes, I think it is good for us to have some document as an area, whether it comes out of this effort or something wider that says how to think about this in your threat modeling, because we have working groups. So RATS is trying to say, how do you do attestation where your device may be compromised, but your device may have multiple different submodules in it, whether it's different layers in a secure boot chain or whether it's different processor contexts. One is secure, one is normal, or whatever, depending on your architecture. And so RATS has to do with attestation, and TEEP has to do with remediation. How do you get out of that state? And so since we're actually doing work in this area, I think it's one that's good to make visible across the area, so as people do their threat models, and even as people do, say, take a dependency on authentication mechanisms, that where the threat model is appropriate, then they can take advantage of, say, attestation that would come out of, say, RATS.
Sure.
Yeah, well, and SUIT too, but yeah, but the most relevant parts here are RATS for attestation, for detection that something is out of compliance in some secure way, and then TEEP for doing remediation as to how do you get back out of that state if the device actually supports that.
Sure.
And there's other ones too, right? Kathleen mentioned SACM. Yeah.
Right. And I guess MLS is looking at post-compromise recovery for keys and things as well. So, yeah.
Ulrich for Deutsche Telekom. I wanted to air my surprise, maybe I'm completely confused. The surprise that there is this thing too kind of seems to be, 20 years ago, did we think about the end devices being vulnerable?
The author is behind you, so he'll.
Is this a phenomenon that after Snowden, we focused so much on the transmission path that offered to certain attacker environments a cheap way of attack and successful attack, and we lost the other parts of the world out of the view? Kind of surprising that at this high level of discussion, kind of such a thing could happen if it actually happened.
Okay.
This is Jeffrey Yaskin. I think it would have been very helpful to my project if this already existed, so I plan to join your mailing list. There's one of the drafts talks primarily about security, while the other draft includes both security and privacy. I don't know if it would be better to combine them or separate them. I suspect the W3C has interesting things to say about privacy, so there should be some liaison with them.
Sure. So when you refer to the drafts, you meant the ones I have here, or?
The 2 that were listed on this session.
All right, okay, fair enough. Thanks.
Ali Rezaki, Nokia. Thank you very much for making this presentation, and I look forward to working with you. I think it will be very important to get the definitions right, define a scope, and also look into use cases where it makes sense to be handled by the IETF here. Thank you. I look forward to working with you.
If I could process and interrupt, where are the blue sheets? You could bring them forward so everyone can sign them.
Harold?
Back.
Harald Alvestrom. I think that it would be good to talk to people outside of the IETF about this. In the W3C, for instance, we have had a lot of work that assumes that the secure thing is not the endpoint, it's the user agent. And the secure thing is executing the devil's code. So we assume that the part that is controlling what we're supposed to be doing is the enemy. On the other hand, they do try to offer primitives so that it's possible for one page to be reasonably sure that it's not itself compromised, so that it can set up a trust environment and trust relationship with a server, for instance, the one it's loaded from, so that the question of who is the endpoint and who is it that we are assuming are being secure jumps around a lot, even within a single application. So I think assumption 2 is rescuable, but you have to shrink the definition of the endpoint down from everything that is beyond the network interface to a thing that is a bit smaller than that.
Thank you. Eric?
Hi, Eric Scola. Yeah, like when we wrote 3552, we weren't like unaware of how antiviruses or malware or like machines got compromised. I appreciate that people are fixating on this point at the internet threat model, the section at the endpoints being uncompromised. I'm prepared to concede it may have been inartfully written, but I think the point there actually still stands, which is that when you want to build a ComSec protocol, if you assume the other side is compromised, at the end of the day, you're not going to be in very good shape. That doesn't mean that that doesn't mean you can't be talking to an attacker, but it means that it's very hard to design security protocols that protect you in the face of the actual counterparty you're trying to talk to having been compromised. And it's certainly true that the ideas about that have expanded over the years in terms of PFS and PCS and stuff like that. But nevertheless, that still is largely correct. This seems like interesting work. Certainly I think it would be good to try to, as we discussed at lunch, expand some of the notions of the endpoint, or expand in some cases, contract in others. But I do want to resist the idea that like somehow like we were so dumb that we didn't understand that like machines can be compromised, because that's certainly not the case. And there's like an entire section about DOS and DOS in here. So it's certainly not the case we didn't understand that you could have like compromised machines on the internet.
Yeah. That's for sure. I guess the other thing I didn't say that I probably should say is that this is not going to solve all the universe's problems. We might make some improvements, but we're not going to, stop all bad things happening or something.
Yeah, Dave Waltermeyer. To Eckhart's point, this isn't something that we can solve with a single protocol either, right? We need a variety of different solutions that are targeted at different pieces of the problem. One of the challenges that I've experienced as someone who's worked in some of the security management protocol space that exists in the IETF is, we've heard a lot of comments that are basically around those kinds of protocols being sort of second-class citizens to a lot of the security protocols that exist, and I think this is bringing out how important a lot of that security management work is to solving these broader problems. And instead of actually shrinking the definition of an endpoint, I think we should actually expand the definition of an endpoint to ensure that we are providing all of the management capabilities that can provide for a more hardened, internet infrastructure in the middle as well as on the ends. To some degree, this is about getting away from the walled garden mentality of looking at, security. Our protocols have a fairly crunchy outside, but we still rely on the squishy inside to be secure, and we need to do more, I think, from an internet perspective to ensure that squishy inside is also protected, because it's terribly easy to attack today.
Hi, Arnaud Tadei, Symantec. So I read the drafts,
I was not aware of this DEDR workshop either. So I'm young here, so I have no idea where this should go. I think it should go somewhere. Just after all the story on TLS that we've been through, we got the feedback that people considered that security should only be done on the endpoint of the communication. So we said, why don't we start on that and try to understand what we are talking about in terms of endpoints, what is it, about the threat model, and we made an internet draft called Capabilities and Limitations of Endpoint Security Solutions, with the intention to simply codify and put words on that. That's called CLES. By the way, I have a side meeting at 4 p.m. in Color, if people want to go there. We got a lot of feedback, and the thing is that we realized we got a number of lessons. First of all, I thought that this was not good value because since we are doing endpoint security since 30 years, everything should have been written on the topic. So first surprise, one, we had no taxonomies on endpoints. Second surprise, the best we could find on the threat models was MITRE ATT&CK, and we are still asking ourselves, is it the right model for us to describe what we need? So we started with two big bad surprises. And so then we started to do an analysis saying, what would be an ideal security endpoint? Of course, it's going to be very hard. And then we started to list all the limits we started to figure out. We put some production data to show what it is we find with real production data about how many attacks the endpoints cannot see and only the network can see, just to give us a real sense of the reality. And we continued with asking ourselves, like your good point about what is the impact of all of that by governments? What is it that they impose on the endpoint as attacks or as regulations, as well as what human rights are seeing there? And finally, the economic cost of all of that, because someone will have to pay for that. And are we making something which is like a Frankenstein? Do you want to have a model by which to secure the endpoint, you need an hypercomputer on each side? So we have asked a number of questions there. As well, in your draft, Steve, you make a good point on social attacks. And so the question is, this is not an attack on the device. This is an attack on the brain. So do you include the person in the endpoint or not? Because this will matter a lot. There is an attack on the brain, on the UX, even before you are on the device. So anyway, the summary is that we have done some work. It's expanding. We have a work program for that. We discussed this afternoon. We think it makes sense. I don't know how you want to tie it. I think I have more ties with Jerry's work because it's more aligned with what I'm trying to do, and maybe it's helpful. So we are happy to contribute, happy to continue to work on that, whatever is the form. So please keep doing. Thank you.
So just to answer, I guess there was a bit of that one was a question, which is how to contribute. I guess it sounds like it's not crazy. We'll make a mailing list and join the list and contribute there.
Hi, Stephen. Elliot here. First of all, nice presentation, and a couple of points. As a side statement, I think it may be worth still reviewing 3552 to see if it should be dusted off and some stuff being looked at from security consideration standpoint. I know I hear growling in the room, but it's there definitely time has moved on. We probably should at least take a stare at it. The second point I wanted to make was that in response to Dave Taylor's, I think actually his work and what you're proposing actually mesh really nicely together in that if you come out with something with some reasonable alacrity, I know that's a hard thing to do in this context, but it could actually drive some of the work that's going on in rats and teeth in terms of saying, well, here's the mess we're in, and here are some solutions that we can get to. Which leads to a question, which is, suppose we get to this internet threat model, and let's posit a world maybe in which teeth and rats aren't quite there yet. What sort of formalisms would you envision addressing a threat model that you would propose? Like, would there be protocol approaches that you could envision that would answer some of the threat models that would address, and how would you envision it apply to the IETF?
Mostly, I don't know. I mean, I think there has been some suggestion in chats we've had with people that maybe there needs to be some kind of descriptions of different threat models that might apply in different kind of protocol contexts. In terms of what kind of formalism, if any, like formalism would be used, I don't know. But there's,
from a programming standpoint or from a description standpoint.
Yeah, I don't know is the answer.
Yeah, Metzger BSI. Yeah, like you just kind of alluded to with different threat models for different applications. I believe that's basically the point where we got to get, because what you ask in your presentation, is it worth to get to one consensus? I believe it's not quite, because like Eka said, it's incredibly difficult to design protocols when I can't trust the other party at all. And that's basically the case when the other party is arbitrarily modified by anyone that's not under my control. So I believe it would be awesome to have such a threat model, but I believe it's also worth considering to have like multiple steps in between that are pretty codified so that we have a decent way of talking what kind of threat model we're building against, and we have a common language on deciding what we're talking about without defining a given threat model for every single individual protocol and standard, but still getting towards multiple use cases.
Yeah, fair. And I think Chris Wood also mentioned that in a chat that there's been some academic work on threat models in various contexts that we might be able to leverage for definitions and things like that.
Ben Schwartz, Google. I think the title of your draft was, does the internet need a new threat model? Something like that. I wonder if a better title would be, does the internet have a new threat model? In other words, it seems to me that across the IETF over the past, let's say, 5 years, there has been a revolution in the way that we think about security, and we've seen a wide variety of security innovations that take a new perspective. One that is apparent to me is certificate transparency, which is a very powerful approach that's very different from the way that I was used to thinking about security 5 or 10 years ago. So rather than thinking about this as an exercise in developing a new threat model, I think it might be more conservative, but possibly easier to think about it as collecting and summarizing the new threat models that as a community we are, and harmonizing the new threat models that as a community we have developed and really advanced a lot.
Yeah, that's a fair point. Much of the routing area would agree, but
So I'm Lawrence Lundblade. I'm co-author of the EAT draft in the RATS working group. I haven't read your drafts, so I'm just going off what I've heard here, but a lot of the discussion has been around compromise. And I think of it differently as what you really want to know is who implemented this thing and did they do a good enough job so that it will not be compromised? Because you can't really, detecting compromise and trying to do that, that's kind of hard. But if you can find out who implemented something, you authenticate the implementer, find out if the implementer is trusted, that gives you a leg up, like, okay, I'm going to trust talking to these guys, but not those guys. So basically, I'm trying to suggest a different way of thinking, a little bit way of thinking there. And really what that is kind of a definition of attestation. I think lots of people define attestation in a lot of different ways, but I'm offering this as kind of a sort of one way to look at attestation, the attestation that Dave mentioned when he was making his comments.
Okay. Martin?
So Martin Thompson, I've been enjoying watching the 3 conversations or 4 conversations layered on top of each other here. And I wasn't going to get up
then you did.
Because I'm on the IB and we've already had this conversation and you don't need that input, but I think it would be helpful for this conversation here to sort of make clear that there's a number of different conversations that's going on here. There is the aspect of the conversation that Eka's talked about, which is that it's very hard to design a ComSec protocol when you are operating under on the basis that the peers that you're talking to are compromised by attackers in the context of that ComSec protocol. I think that's pretty well understood. There have been some evolutions in the way that we understand how that operates, such that we might want to put bounds on the extent to which we believe that to be true, and there I'm talking about things like the PFS and whatnot. But it seems to me that the discussion that the workshop and the drafts is pointing at is something else, which is that we're talking about alignment of incentives more than anything else. The previous speaker talked about attestations, which is another thing entirely, which I hadn't really considered, but it's probably more in the first bucket than the second one. But when we're talking about these things, Ben was clearly talking about, I might be fine knowing that my connection is secure in the sense of TLS to a given endpoint, but I don't know what they're doing with that information once they've got it. And maybe there aren't necessarily any alignment of incentives between what I want and what they want to do with that information. And that's one of the major failings of the web as we have today. So thinking about what you want to do with this work in either the first context or the second is probably what we need to do, and being very crisp about that would be quite helpful, I think.
Okay, thanks. Hannes?
Hi, this is Hannes. Stephen, that's nice that you wrote things up. However,
that's usually the preamble to Anders.
You know, I try to improve, but what I don't see, and maybe you can shed some light on this, is where would the IETF contribute to this? Because, for example, Dave Taylor provided some examples on current activities that don't make this assumption that you previously cited. And on the other hand, it very much makes those assumptions just for a smaller subset of the endpoint, like talking about the secure world being secure rather than the rest. And the OAuth case is not too different. And so the IETF is in a business of providing sort of protocols for interoperability. Where would the IETF contribute to these type of things, endpoint-related security mechanisms, so it doesn't make, so it does lead to a difference?
So I guess I'm a bit confused with the question. I mean, so I think that this work would be IETF work. I mean, it's a mailing list for the IAB or something, but it's IETF work.
I think just writing things up is like write a book about it.
Sure.
That would be cool. Nice pictures and everything. But that's not really getting anywhere.
Correct. I mean, I think I think part of this would be figuring out what a whole bunch of people think, but then another part of it is trying to turn that into something that's actually useful for people doing protocol work in the IETF. So it has to be.
And that's the part that I'm missing. I don't see that those aspects of where's the info for me as a protocol designer that would make a difference. I'm missing that part.
I mean, I guess we've had some cases, examples given. Yari, I guess, is going to go and give another one. If I take the idea of not only thinking about use cases, but abuse cases, for example, I think that is a defensible thing that you could say, this is something that you could argue that should be part of a BCP in the IETF somewhere. And that's one example. There may be more, maybe this will fail. I don't know. Yari, I guess, has an example.
Yeah. So I just wanted to interject slightly and say that, this is really hard. What Stephen said is correct, that we need to move forward and have some advice that would actually be useful for IETF. But I do think that there are some things that you can take into account. So I've certainly personally done that in recent work, adding PFS to my protocols that don't have that, thinking about system architectures where I'm spreading some information for too many nodes when I could have, kept it to need-to-know basis. I've, looked at things where we are sending information to centralized parties in the internet where we perhaps wouldn't need to, and so on. So there are things that we can take into account at the IETF work also. At least that's my experience. That doesn't solve everything under the sun, but maybe a little bit helping.
And if I could add, because I can't one of us has to be up here, so I'll take my prerogative up here. I mean, it's about residual risk. It's not clear that the IETF can address kind of all of those, but the ability to kind of document those, put them out there, then when folks take IETF protocols and they compose them with other things, that we've reminded them that they need to consider this in the integration process.
Daniel Kahn-Gilmore, ACLU. So I'm happy that we're having this discussion.
I'm a little bit concerned about the idea of the IETF trying to figure out how to reach into the endpoints themselves and do a lot of stuff on the endpoints, because I think we haven't been very good at doing that. That doesn't mean that we maybe shouldn't try, but I can imagine folks who work on the endpoints being territorial about that. But one of the things that I don't think it's just about the network transmission stuff versus the endpoint. I have a lot of sympathy with what Ecker said about it's difficult to design a communications protocol where you assume the other party is malicious. But the thing that I think is missing there is a sense of time, perhaps, about what happens outside and around the protocol. So when I think about that, I think of things like linkability, right? Where where I may want to interact with with this external party, but I want to make sure that that interaction is distinct from other interactions that I've had with that same party. And so there's a gap there. And I think thinking about it in terms of time, maybe more than transmission versus endpoints, might be a useful frame.
Sure, thank you.
Brett Jordan. I read your draft, Stephen, and I read Dominique's, but I didn't read the other one, so I apologize for that. I wasn't also aware of any meeting that we were having about this. So I do think this work is important. It's very critical. I do fully support it. And even if that means at the end of the day that ComSec protocols have a section in there on risk management for operational security to help illustrate what this means and help people, put this into their risk profile when they're doing risk management in a large enterprise or a large organization, I think it's really important. I do support it, and thanks for doing the work, for you and Dominique. Both drafts were great, so thanks.
Ben Kadek. So I came down here to the floor to share some thoughts as an individual, and they've been changing over the course of listening to everybody else. Maybe I should have just stayed up there. But to sort of maybe try and summarize and synthesize from what we've been hearing, it seems like it's probably going to be useful to recognize that there are more subtleties and gradations, and to sort of broaden the horizons about what we're thinking about as we design protocols. We may not need to try and reach into the endpoint with what we're doing, but we could think about, maybe there's not just a single endpoint. Maybe there's multiple different layers on the endpoint with things that have different layers of trust that are implemented more robustly, that are potentially more susceptible to being controlled by an attacker. And we might want to think about things in time. What are the broader effects of what we're doing over time, and just to sort of recognize that we have not just a binary black and white situation. We might be talking to someone who we trust to correctly implement their software and to correctly implement the protocol, but as Martin was saying, to have slightly misaligned incentives. So it's not like we're talking to a completely adversarial relationship. And so there's some things that we can do with them, but we're not just going to hand over all of our data to them blindly, and we need to be a little more thoughtful about what we do and what we send. Ari was talking about that too.
Yeah. Okay.
So Ben said a number of things that I wanted to say, so thank you. I also wanted to sort of echo what DKG just said. I think one thing 3562 does quite a bad job of is sort of on privacy. Now, it wasn't really sort of like thing at the time, but doesn't do a good job at all of recognizing the ways in which our protocols create privacy risks, and especially the way in which sort of large-scale use of these protocols creates, the addition of a very small, a large set of small individual privacy risks, which will put together create a real problem. So I think that would be something which really would benefit from something. I'm not quite sure what that would be. But I don't think we really had the notion at the time that sort of high dimensional, like sparse data sets were just such a big problem as they've turned out to be. And so having something, and as Arvind reminded us basically, yesterday. So that's something which I think really would be nice to hit, which I actually didn't catch so much in this presentation, which isn't intended as a criticism, but just seems like another thing to keep in the hopper.
Sure. Wes.
Wes Hardiker, ISI. You already know I like this work because we've had that conversation. I really miss the days where I could open a socket to a port less than 1024 and know it was going to be secure. That was awesome. Come a long way since then. And Ben said exactly actually a lot of what I was going to say, in that in society we have this notion of elevated trust, and as we negotiate and as we communicate with somebody, our level of trusting them comes up. And I think there's a few IEB documents that are going to come out talking about that as well. But we're missing that in the protocol space, and yet users do this all the time, right? When you log into a website, frequently you don't log in first. I was just doing some United searches a second ago, right? They didn't ask me for my password until I got to the point where, oh, it's time to commit. I also remember back in the days where you'd go to HTTP sites and use them for a long time, and then it's like you had to submit your credit card, and a lot of times they didn't even put the submit your credit card number in until you just said, trust me, the following link will go to a secure site. But we have this notion, and people have this notion of elevated trust all the time. Companies ask it of us all the time. Now I need your two-factor authentication. Before I didn't. Why we don't build that into sort of even more base protocols, I don't know, and why we don't assume that maybe both sides need some set of elevated trust. Because there are certain sites I certainly won't give a credit card to, even though I may go browse to them.
Sure. I think you're first, Ed.
Thank you. Kirsty P. from NCSC. So thank you for revisiting this topic. I think it's a very important topic generally. I've heard a lot of discussion in the mic lines about endpoint security and considering different types of endpoints and classifying them and stuff. And I would just like to highlight again the CLES draft. That is an individual submission at the moment, which talks about the capabilities and limitations of endpoint security solutions. So before we redo that work, I'd just like to direct people to that. And I would also say that, sorry, that's distracting. And I would also say that there's another draft that goes with that that's also got CLES in the name that talks about a taxonomy so that you can describe these endpoints differently. Different endpoints have different characteristics. And so when you are connecting them, you can expect different behavior. And I just wanted to highlight that again before any work in that same space just gets redone under a different name.
Okay,
Thank you.
Paul Turner. In the definition of thing 1 and thing 2, and I understand that thing 2 now is in flux, where would you place the IETF protocols or the communication mechanism that they enable being used as an attack on the endpoint to compromise that endpoint? So you've got the endpoint assuming to be compromised, but if the network is being used and the protocols here are being used as part of that communication, have you considered that as part of the model?
Well, I think probably mostly not, unless there's some technical detail that's kind of interesting. But I can send you an email that's threatening. That doesn't mean there's anything wrong with RCA 22 and its derivatives. So my initial reaction would be I can't think of a way in which we'd end up there, but maybe.
But if you're looking at a threat model, it's not about solving that at this point. It's about considering that threat.
Oh, well, yeah.
And so understanding, for example, as we encrypt connections, if somebody's able to use those as an attack mechanism to get to a compromise of the endpoint. So it's something to consider.
Sure. I mean, I guess I would argue that just because something's encrypted doesn't mean it's an attack. So
the
attacker can send packets in clear or encrypted or.
Absolutely agree.
I mean, clearly, if an IETF protocol enables a better DDoS reflection attack because of packet sizes or something like that, that definitely is something we need to consider. I'm less sure as to whether the fact that we turn on encryption makes things bad is a possible thing that we should be contemplating here. If that's what you meant, but maybe it wasn't, I'm not sure.
Well, no, but if we're thinking about the point that the endpoint can be compromised, and this body focuses on communications, is it important to look at what contribution does the communication have to compromising that endpoint as part of that threat model? So it's again, something to consider as part of what's been a pretty broad, view, which I appreciate.
Sure, okay.
Lawrence Lundblade. Thinking about maybe breaking thing 2 down into thing 2A and thing 2B, where thing 2A is the equipment, software, and implementation used to do something, and thing 2B is the service or the entity that's actually operating stuff. So I believe the attestation and what we're going after in RATS and EAT is thing 2A. It's the implementation. But a lot of the discussion here around is around privacy and trusting the service, with your credit card or your data. That's thing 2B. So the equipment and the implementations could be great, but the guy that's operating the service is selling it out the back room to somebody else, or he forgets to do software updates or something like that. So that's really more, that almost seems like server auth or service auth, which is, I consider, quite different from attestation. And I think I'm hoping RATS and EAT stays away from the service part and just sticks to the implementation part.
Okay.
David with Rakuten. I just want to try and attempt to maybe clarify what Paul, the previous person at this mic, was trying to say. I don't think necessarily it was work that should be done, but probably the idea is that here we assume the end system engaging protocol is not being compromised. I think there's like a third assumption, which is that I am not an attacker, the person sending the transmission. But I think, so the consideration is, an example you said, like, why would you think encryption is a bad thing? I don't think anybody wants to say, hey, encryption is bad, let's stop doing it. But then it does have negative security impacts as well as positive. I think yesterday they're mentioning, for example, researchers can't see what IoT devices are doing because it's all encrypted. So then it has privacy implications. You have devices now sending your data out to who knows where, and you don't know because everything's encrypted. Now, that doesn't mean we should stop encrypting things. It doesn't mean maybe even we should think about this, but I think that's the general concept.
And as you looked like you were answering that point, was that correct? Am I correct?
Yeah, I was trying
to
get in there because I feel increasingly uncomfortable in that discussion, because it started off with, to me, like, okay, there are challenges with endpoint security, but I hear people saying, that should be the reason why we then man in the middle our existing protocols to make things even worse. What I would like to offer an alternative. As you know, I work for ARM, and we also have our friends from Intel in the room. We constantly increase or add features to hardware, providing extra security features. And of course, it's a race against lots of the attackers who are very, very motivated, commercially funded, et cetera, But we would definitely appreciate support also from this community in making use of those hardware security mechanisms. We have lots of open source projects, and I can send pointers to the list on what we do. And if some of you guys who care so much about security want to improve endpoint security, help us to improve some of the operating systems, the firmware, and some of those other mechanisms, rather than just writing one document after the other and say, oh, the world is so bad.
So let me suggest that we don't have the breaking TLS discussion, unless the ADs want to do it all over again. But so in general, for me, in this work, we assume thing one is still necessary. And I think for me, that closes off some of those discussions about funny, non-optimal crypto things some people might like to do.
So I'm Debbie Cooley from NSA. I'm going to take you out of the weeds and back up to the space where you belong here. Determining what threat is applicable to the system you're in depends on what you have purview over, right? So you have access to this space, and you need to consider the threats that are applicable against that space. You're begun to reach into the endpoints in the IETF where you perhaps haven't in the past. And so the endpoint now comes into the purview where it may not have been in the purview before. So it needs to be a holistic look at threat based on what the system is. The attacker is always going to be one up on you.
Sure.
Always, right? Because you have to protect everything, and he just has to attack the thing that's the easiest. And he wins, right, at that point. So you have to spread your resources out amongst the whole thing, and he gets to pick the one thing that you've missed, right? So the first thing you need to decide is exactly what your space is, what part does the IETF have the most ability to affect, and then you design your threat documents, your threat statement of threat to meet that. If you want to delve into the endpoint security case, which you have already started to do, then that comes into it, and then thing two becomes part of the game.
Yeah, I mostly agree. I guess where I would phrase it differently is I don't think the IETF has reached in there. I think the definition of endpoints has changed over the last decade or so in ways that have some impact on our threat model.
So we need the endpoints to be good, right? So the thing two statement needs to be true in that we need the endpoints to be not compromised.
I'm not sure I agree in general, no.
No, so
I could put it this way.
It's a positive statement, right? So I need my endpoint to be a good thing. I need not to have an attacker inside of it.
So one of the things when discussing this we've been talking about but haven't come to some definition of is maybe if you think about this as a protocol between multiple parties, if they're all compromised, probably it's game over. But if one of them still isn't, maybe there's something we can do better than we're doing now.
So if that party has access to everything, then I would still say game over.
It depends. We maybe have to do better than nothing is I guess the point. Okay, we'll join the list and we'll see. I mean, we're not going to solve all world hunger here.
But I do think you need to look at things holistically. It's not just a one-size-fits-all game, right?
Absolutely.
So it just depends on what the protocol is and what it affects based on. It's going to determine what you need to care about.
Yeah, and it's really unclear whether we can come up with something generic enough and then reduce it to something simple enough to actually be usable. Those are all unclear things, yeah.
Yes.
All right, to be clear, we're cutting lines at the folks that are in the queue right now.
Okay, so Arnaud Tadei again, from Symantec. So I think it's very clear that we have a problem of just naming stuff. So somebody said, what is the common language to discuss? What is an endpoint? Actually, it's even worse. We don't have a language to describe an attack surface. Internal attack surface, external attack surface. That's the first thing. We don't have a model to describe the attacks. And then back to the gentleman from ARM, I think that very good point. They are doing stuff on the hardware. People are doing stuff in the operating system. People are doing some in the application. And on top of that, there are other things you need as third party on top of that. So we don't have a model to holistically look at the security for all of these pieces together. So I understand the debate. What does it mean for protocol designers? I'm too young here to discuss that. The only thing I can offer through the work we are doing with Mark over there is try to put words on things so that at least we start from the same baseline. And I promise you, it's already very hard. So if you are interested, please help. But at the same time, please, you and Jerry, give us input, what you need from us. I don't know. But maybe we have a way to find a good collaboration model. So thank you.
Kathleen Moriarty. So I do think we need to go into two, and that we have been already. I think where I differ from Deb's comment is that, I mean, ideally we'd keep everything secure, nobody would ever get in, but work like SACM and RATS helps us to detect if something has been compromised. So if there's some sort of change in your posture assessment or system hygiene, whatever phrase you want to use in the SACM sense, and that can be signaled, you can detect and then thwart an attack before either privilege escalation happens or lateral movement within a network happens. And so, the detection piece is something we should consider, right? So you may not keep your system completely secure, but being able to detect that attacker and thwart them as quickly as possible. You can look at like Lockheed Martin kill chain or a MITRE attack, and it does benefit you to catch them early, and that work has made a lot of progress in recent years because the time to detect attacks has gone way down, and it's really detecting change. So if we could put more energy into things like SACM and make it really work, and RATS, I think those would be big gains and would help against if this is in our threat model, then we can show that we're doing real things to aid in that objective.
So just following the previous comment about IETF's workspace. So historically, IETF has been in the security space has been focusing on identifiers and proof of possession. So all the way from ISOCAMP, if you guys are around, then Harkin's doing V1, right? IPsec, everything's about, the only way I can prove who I am is possession of private key. I think we should extend that to proving my state. So if I'm talking to Yari, besides showing me your proof of possession, show me also proof of state. And this is what the RATS people are doing. This is what the PCG people have been doing since 1999. Again, it's a consortium, but I think the threat model should address the information model that RATS is doing. Oh, the other way around. Correct me, people. Maybe the RATS information model needs to inform the threats document. But
sure. Yeah, I mean, personally for me, it's not clear how broadly applicable some of these things are, but I think they're definitely inputs that need to be looked at, and there's bits probably that are cropping up all over the place that are relevant here. So. Yeah, so I guess we'll have a mailing list. It sounds like we have 1,000 opinions, so
So
it'll be fun.
Stephen, Yari, Brian, and Ted, thanks for bringing this to us. We'll continue talking. It's great that we're thinking and taking fresh eyes on the problem. And Stephen, there will be a mailing list coming where we can continue to discuss this. We'll post something to SAG so we can continue this on a dedicated vehicle. Okay, so time-wise, we're now in the open mic portion. Anything you want to talk about, come on up. While we're waiting for those ideas, where are the blue sheets? Could the blue sheets come up? I see one. Where's the other blue sheet? Okay, it's there. If you could sign it. All right, at the mic, going once, going twice. All right, thank you so much. Have a good rest of the afternoon. I did notice that. That's impressive. It's always good to learn that Thursday afternoon. It should be good. It's just not on. All right, thanks. I'll take that.